Let's start the new topic, magnetic flux. So magnetic flux is very similar to that of electric flux. And to define the magnetic flux is also very similar to the electric flux. Now, the magnetic flux linked to any surface. So this is now we starting the definition of magnetic flux. In a magnetic field, the surface should be placed in a magnetic field then the magnetic flux is the number of magnetic field lines. So this is the actual concept which you should have to remember. See, I am writing magnetic field directly now as vector B, because you know the magnetic field is denoted by capital B and the vector sign, because the direction is very important in it. Now the magnetic field lines crossing this surface normally. So this is the definition of magnetic flux. So this is nothing but a complete number. So to denote a number, there is no necessary of direction. So I can conclude that magnetic flux is a scalar quantity. Now, in order to analyze, you just have to see the figure. So this is the figure in which magnetic flux through a plane. So this is the plane. It is having the surface area is A, that is placed in a uniform magnetic field, and that is B. Now, the magnetic flux can be written as, its symbol is phi, and it is defined as the number of magnetic field lines passing through the surface normally. Now see, this direction of surface A is for normal. It's for normal direction because the scalar product and there are two vectors. So we know that the scalar product of two vector quantities will give you a scalar. And now if we further expand this equation, then B dot A is BA cos theta, where theta is the angle between magnetic field and the surface area. So it is also need to be written over here. the magnetic field and the surface area. Now, here the above equation which we have used is for uniform cross-sectional or uniform magnetic field and particular type of surface. But the above equation can be further expanded for a curved type of surface and non-uniform magnetic field. So, let us consider a case in which there is a curved type of surface and a non-uniform magnetic field. So here a curved type of surface and non-uniform magnetic field is shown. Now, for such kind of magnetic field, we have taken the different cross-sectional areas. This is DAI. So this is my DA3, DA2, DA1, anyone you can consider. And for that, the magnetic flux through the surface is given by phi is equals to B1 dot DA1 plus B2 dot DA2 plus B3 dot DA3 plus so and so. So generally I can write this equation as summation over which here the DA1, DA2, DA3 are area elements. So I am consider here the all area elements. So here the summation is for all area elements. And here I am putting the subscript, so Bi dot Dai, where I you can choose from the area elements are provided. Now, we have studied only about the quantity but not their property. So let us consider some of the properties of magnetic flux. So, any physical quantity has its SI unit. So magnetic flux has its SI unit of Weber. See, when you write the full name, then you have to write all in small manner, and if you want to write only first two letters, then they will be also in small letters. So it is written either as WB or Weber. The other SI unit which you can consider as Tesla into meter square. Therefore, we can conclude one relation. 1 Weber is equals to 1 Tesla into meter square. From this, many MCQ questions can be arised. Now, suppose you assume one condition that if the normal which is drawn to a plane point outward in the direction of the field, then the magnetic flux will be positive. So, when the normal is outside, means outward the direction, the magnetic flux is positive. But how can you prove the above statement mathematically? So, for that, whenever it is normal outward the plane, that means theta is equals to 0, and therefore according to the equation of magnetic flux, phi is equals to Ba cos theta is equals to Ba cos 0, but cos 0 is 1, so phi is equals to Ba. So this is one most important equation which you can use for illustration also. Now, if you consider the totally opposite direction of the normal, then what happens? Then in that case, the value of theta will be of phi, and in that case, the equation will be phi is equals to Ba cos phi, and hence cos phi is equals to minus 1, so phi is equals to minus Ba. That is equation number 4, and hence here the phi is negative. With this, our magnetic flux topic is over. Now we will see the important law, that is Lenz's law.